All right, well, hello, geometers. As we continue our study of angles and particularly inscribed angles inside of a circle, let's look at a few examples there. Now, there are a handful of examples in your notes, and I'm going to do a couple of them and leave the others to you. If you have a question, we will certainly talk about it in class or in a live session. So without ado, let's work on number one here. So we know the measure of this angle here is 61 degrees, and we're asked to find the measure of arc ST. Okay, so arc ST, this is the one that we're looking for. Okay? And again, there are many different ways to solve this problem, but I'm going to use a method that I think is based on what we've been doing already. Okay, so first, using this angle here, and I'm just going to extend that angle there out here a little bit further. Okay, so this is an inscribed angle. Angle TSU is inscribed, and it intercepts arc TU. Okay, it intercepts arc TU. So what that means is that this angle has to be half of the measure of this arc using the inscribed angle theorem, right? So if it intercepts this arc here, the angle must be 1/2 of that arc. So that tells us that this arc is twice the angle. So another way to say is that the measure of angle TSU is equal to 1/2 the measure of arc TU. And since this is 61 degrees, then we can solve this equation pretty simply and know that this arc here has to be 122 degrees. Okay? Now, if this arc right here is 122 degrees, and if you notice here that P is the center of the circle, so arc SU is 180 degrees. So what that means is that the arc that we're looking for, the measure of arc ST, has to be equal to 180 minus the measure of arc TU. Okay. So 180 minus 122 gives us 58 degrees. So again, the yellow arc here that I've highlighted and the red arc make up a semicircle, so its measure is 180 degrees. Therefore, the red arc here is 180 minus 122, which is equal to 58, right? And as I said, there are a few other examples here that I'd like you to work on your own, and then we'll check our answers together. Right now, I'm going to continue on and look at maybe a completely different type of problem. Right. So in this example here, I am going to look at to solve for the missing angles here of this quadrilateral. Now remember that a quadrilateral here is inscribed. It's all 4 of its vertices are on the circle. So because it's inscribed, the opposite angles are supplementary. So look back in the notes and the videos at some of the other examples, and the proof for this, that the opposite angles have to be supplementary. So that means that 63 and 3x have to be supplementary, so they have to add up to 180. Okay, so the opposite angles, angle P and angle R, 63 and 3x add up to 180, and from here we can solve. So 3x is equal to 180 minus 63, which is equal to 117 degrees. Then 117 divided by 3 is equal to 39. 117 divided by 3 is equal to 39. So we know that x is equal to 39. All right. And now your task that I leave up to you is to solve for the value of y, as well as to complete the rest of these problems in this exercises. As always, thank you for watching. Keep working hard. Ask for questions if you need it, and have a wonderful day.